Hey guys, in this video we are going to learn how to divide polynomials using synthetic division. So instead of doing long division, which is what we were doing before, and they call it long for a reason, it took us 30 minutes to do 4 problems. Synthetic division doesn't have all the variables in it, so we can do it quicker. The limitation of synthetic division is your divisor has to be linear. You know, I can't have a squared here or anything. And it has to be a binomial. Okay, it has to be a linear binomial. So let's see. On the first 4 problems, let's see how many of these we could have used synthetic division on. We could have used synthetic division on number 1, because that's a linear binomial. I could have used synthetic division on number 2. I could not have used synthetic division on number 3 because it's a trinomial. Alright, synthetic division is only going to work for binomials. And I could not have used synthetic division on number 4 because it's not linear, it's quadratic, it's squared. Okay, but you'll notice that all of these linear binomial, linear binomial, linear binomial, linear binomial. So here's how synthetic division works. Start by making up, let me zoom in. Alright, this is going to take up 3 lines on your notebook paper, okay? So it's going to be kind of like this. I'm just doing this so, you're doing this on notebook paper. I want to show you how this will look to you. Alright, so pretend this is your notebook paper. This is going to take up 3 lines on your notebook paper. You start by putting a box right about here. Okay? Now, on the same line as the box, you're going to just put the coefficients of this polynomial. Okay? So I've got 2, 2, this is a 1, this is a negative 1, and then negative 1 itself counts. So let's just write all those down. So I've got 2, 2, 1, negative 1, and negative 1. Alright, I've written all the coefficients. Okay, you're going to draw another line right here. Okay, so you're sort of skipping a line. And then in this last column, put another box. Okay, that's going to be your remainder. Should put a little note. This will be your remainder. Okay. In this box, we're going to put sort of the opposite of this number, if you will. Okay, this is going to wind up being a negative 1. Technically, what it really is if we took this x minus 1, if we took x plus 1 and set it equal to 0 and solved it. So, we would go minus 1 on both sides. So that would be x equals minus 1. Okay, and that is what goes in the box. Alright, I said it to you that way because let's say if it had been 3x plus 1. Okay, well, it won't just be a negative 1 in the box now. If this had been a 3x plus 1, I would have to set 3x plus 1 equal to 0. Alright, I'd have to subtract 1 from both sides, so that would give me 3x equals negative 1, and I would need to divide both sides by 3, and that would give me x equals negative 1/3. Okay, and that would be the number in the box, would be negative 1/3. So you have to be very careful, but that's coming much later. So right now it's nice and simple. So we had x plus 1. So this will be negative 1. Okay. This number, by the way, well, you know what, don't worry about it. So here is the process. First thing you do, the first number you just bring straight down. Okay, so that's 2. Once you have that number, you multiply it and put it in the negable space. So 2 times negative 1 is negative 2. And then you just combine like terms and repeat. So if I put these together, I get 0. So again, I multiply and put it in the next available space. So 0 times negative 1 is 0. Combine like terms, that's 1. Repeat. 1 times negative 1 is negative 1. Put it in the next available space. Combine like terms, you get negative 2. One more time. I do this times this and put it here. So negative 2 times negative 1 is positive 2. Combine like terms, and that is 1. Okay, so 1's your remainder. Now, we need to get our variables back in. You know, we need an answer that looks more like this, with some sort of a polynomial, and then we can make a fraction out of the remainder. So here's what you do. These are the coefficients of our answer. So I recommend that you read this from right to left. Okay? So on the far right, this is always going to be the constant. So I'm not going to put any x's on that. Because see how, like this one, for example, this is just a constant? That's how it goes. So this first number represents the constant. The next number over should be the x term. So like this will be the x term. The next number over, and it's positive, so I'll go ahead and put plus. The next number over would be the x squared term. All right, so constant, x term, x squared term. And the next number over will be the x to the third power. Okay, so let's just recopy this and clean it up. So what I have is 2x to the third power. Then I've got this 0x squared. Guess what? I'm not going to write that. 0 times anything is 0, so that's nothing. I'm not going to put it down. And then I've got this plus 1x. So I'll just put plus x from that. I'm not going to put the 1. And then minus 2. Okay? That is the trinomial part. Now for the remainder, again, I need to add this on as a fraction. So I'm going to do 1 over. And it's going to be over the divisor. So the divisor was x plus 1. So it's going to be 1 over x plus 1. So this will be your answer to number 5. All right, soak it in. All right, number 6. 4, 3, 2, 1, 0. All right, I always check to make sure there are no missing terms. So start with your box. Okay, now the coefficients. 1, 2, negative 5, 3, negative 1. So here I go. 1, 2, negative 5, 3, negative 1. Okay, draw your line like this. Your last column is the remainder. Whoa. Okay. So once again, here is the process. First number, you just bring it down. Kabam. Now you multiply. Oh, I didn't fill in the box yet. Ha ha. What number is going to go in the box, people? Will it be negative 1? No, it's going to be positive 1. You're right. You're geniuses. All right, this is going to be a positive 1 in here. Okay, because it's like we set that equal to 0, and we added 1 to both sides. So x equals 1. Okay, that's what goes in the box. Anyway, so I've got to do 1 times 1 is 1. Combine like terms, that's 3. 3 times 1 is 3. Combine like terms, that's negative 2. Negative 2 times 1 is negative 2. Combine like terms, that's 1. 1 times 1 is 1. Combine like terms, that's 0. All right, so this time there is no remainder. 1 times 1 is 1. Combine like terms, that's 1. 1 times 1 is 1. Combine like terms, that's 0. 1 times 1 is 1. Combine like terms, that's 0. 1 times 1 is 1. Combine like terms, that's 0. 1 times 1 is 1. Combine like terms, that's 0. 1 times 1 is 1. Combine like terms, that's 0. 1 times 1 is 1. Combine like terms, that's 0. 1 times 1 is 1. Combine like terms, that's 0. 1 times 1 is 1. Combine like terms, that's 0. 1 times 1 is 1. Combine like terms, that's 0. 1 times 1 is 1. Combine like terms, that's 0. 1 times 1 is 1. Combine like terms, that's 0. 1 times 1 is 1. Combine like terms, that's 0. 1 times 1 is 1. Combine like terms, that's 0. 1 times 1 is 1. Combine like terms, that's 0. 1 Okay, that means it divides in evenly. Okay, so this is our constant. This will be our x term. This will be our x squared term. And this will be our x to the third term. So that's what I recommend you do. Work from right to left. Constant, x term, x squared term, x to the third term. Okay, so here comes the actual polynomial. I have x to the third power, all right, and then plus 3x squared, and then minus 2x, and then plus 1. All right, and there was no remainder. So this is the final answer for number 6. Okay, how about number 7? All right, I think you'll agree this is much quicker than long division. So given the choice, you're going to want to do it this way every time. Well, if you have a linear binomial. All right, number 7. Hey. Oh, you know what? I just realized you're not doing this on notebook paper. You're doing this on the same worksheet I'm doing it on. But, yeah, so anyway, it's still helpful for you to see what's happening, but no notebook paper. So let's put the box right here, and the coefficients, let's see, 3, 2, 1, 0. All right, I keep waiting to have a missing term so I can put that 0 in there and show you guys how it works with synthetic. But so far, I haven't had any missing terms. I'm kind of hoping the next one has a missing term. So the coefficients are 1, okay, so 1, -4, -9, and 36. Okay, you put your line like so, and your remainder will go here. Oh yeah, inside the box. What goes inside the box, people? 3, okay? It's because of setting that equal to 0 and adding 3 to both sides. You get x equals 3. That's why. So here we go. First, the 1 comes down. Multiply, put it in the next available spot. So 1 times 3 is 3. Combine these, that's -1. -1 times 3 is -3. Combine these, that's -12. -12 times 3 is -36. Combine these, you get no remainder. Okay, once again, from right to left, this is the constant. Okay, just like the 36, the constant is on the end. So this is the constant. That makes this the x term. That makes this the x squared term. So let's recopy it, make it look prettier. So what we have is x squared minus x, we don't need that 1 anymore, minus 12. So this time it divided in evenly, so that's your answer. Okay, and last problem. Ah, there we go, missing term. Hey, missing term. So watch out, guys. Do you see what I mean about the missing term? There should be a 0x squared. There should be an x squared term. 3, 2, 1, 0. So if there's a missing term, make sure you put a 0 term as a placeholder. Okay, so the box goes here. The coefficients are 2, and then 0. Put it in red to make it super clear. 2, 0, -45, -7. Okay, in the box, I will have a positive 5. Okay, it's what you get by setting this equal to 0 and solving. You wind up adding 5 to both sides. You get x equals 5. So that's the reason why it's a 5. Okay, can a brother get some lines? So put a line right here. The last column will be for your remainder, so put that aside. Okay, let's do this, people. Bring down the 2 first. Now you multiply and put it in the next available spot. So 2 times 5 is 10. Combine these like terms, you get 10. 10 times 5 is 50. Put that in the next available spot. Combine these and you get 5. 5 times 5 is 25. Combine these and you get 18. Okay, so this time we have a remainder. This 18 is the remainder. Okay, so from right to left, this is the constant. Just like -7, the first one you come to from right to left is a constant. That makes this the x term. That makes this the x squared term. Okay, and all of these should be starting off, these are all positive. Okay, so that means rewriting it to make it look pretty, we've got 2x squared plus 10x plus 5. Okay, that's the trinomial. And then the remainder, we do plus 18 over the thing we divided by, which was x minus 5. All right, if you're curious, you should try going back and doing one of these problems using long division. And what you'll find is, even if we do it, like this way, we're still going to wind up getting the same answer. Okay, so we did 4 problems, and that took about 17 minutes. All right, that's about half as long as it took to do long division. Okay, so anytime you have a linear binomial, you really want to use synthetic division. It's so cool. I hope this was helpful, you guys, and I hope you didn't just copy off of me. Please make sure you can do all these problems by yourself, and I will see you on the next video.